Here's a question from one of the kind of challenging problems from 8.5 that was asked this week, and I wanted to help with part D. Basically, you're given this model. Okay, it's a model for the distance a bob of a pendulum moves, and the distance is a function of time. And as you can see, there's an exponential damping factor, and this cosine part is what does the swinging back and forth kind of. Okay. And the question was particularly about part D of this, so I'm going to jump down to part D. Here's my model, okay, for the displacement. It's this damped oscillation. And the question is, what is the displacement of the bob at the start of the second oscillation? Okay, and so here's what my thinking is. And earlier, if you were to graph this function, it would look like this last one here. So the start of the second oscillation is basically after a single period of the cosine function. Okay, so starting from t equals 0 is the first oscillation. Once I hit the second, this bottoming out where my cursor is right there, that's what I consider the beginning of the second oscillation. Okay. Now, what we basically then have to do is think about it. Okay, well, how the hell do I figure out what that is? Because if I know what the period of this function is, basically I can try to figure it out based on that. So here's kind of my thinking. What I thought was, all right, well, cosine of theta, here's my thinking. Cosine of theta equals 1 when theta equals 0, or 2 pi, for example. And then 2 pi, 4 pi, 6 pi, things like that. So the start of the second oscillation is kind of when the inside would be 2 pi. Okay, so I just said, okay, well, the inside of my cosine function looked like this ugly radical over here times t. So I said, okay, well, the start of the second oscillation, I'll give it that time t star, and I'll solve for t star in this equation, okay? So I just did that, and it's real simple. You just divide by the radical. It's ugly looking, but there's your t star, okay? Now then the displacement of the bob is then based on look, if you think about it, when t equals this t star, the cosine part of the model is easy. It just becomes 1, and the displacement just becomes the rest of this here. Okay, so what I really have to compute now to figure out the displacement is negative 20 times e to the minus 0.05 t star divided by 40. Okay, so that's what my displacement is going to be. So all I got to do is figure out how do I plug this t star into this function. And that can be a complicated thing on your calculator. I plugged it into Google because that's what I typically use for a calculator these days, and it worked out great. You can use a TI calculator to do it, or some other smart machine, but I just use Google to do it. But that was my thinking for the problem for part D. I hope that helps. Basically, you didn't need a graphing calculator to answer that portion. You could just work it out based on the model that was given.